Have you ever gazed at the night sky, lost in its infinite expanse? Have you ever felt a sense of wonder, a deep curiosity about our place in the cosmos, and wondered why the universe seems so perfectly suited for life? It's a question that has captivated philosophers, scientists, and thinkers for centuries. Is it mere coincidence, or is there something more profound at play? When we examine the laws of nature, the very fabric that governs our reality, we find that the universe is balanced on a razor's edge, a delicate equilibrium that allows for the existence of stars, galaxies, and ultimately, life itself. Change any fundamental constant even by the slightest fraction, and life as we know it would be impossible. The universe would be a cold, desolate wasteland, devoid of any possibility for complexity or consciousness. This isn't just a philosophical musing, it's not simply a matter of pondering abstract concepts. It's a real scientific puzzle. The fine-tuning of the universe presents a challenge to our understanding of physics and cosmology. Why do the rules of physics allow for stars, those colossal nuclear furnaces that forge the elements necessary for life, planets, and conscious beings? Why is the universe structured in such a way that it can give rise to complexity, awareness, and ultimately ourselves? Are we just lucky winners of a cosmic lottery, a chance occurrence in an otherwise indifferent universe? Or is there a deeper reason, a hidden purpose behind the seemingly improbable existence of life? Some suggest a grand designer, an intelligent being who meticulously set the dials just right to create a universe capable of supporting life. Others imagine a multiverse, a vast collection of parallel universes, each with its own unique set of physical laws and constants. With countless universes, an infinite array of possibilities unfolding across the cosmos. And we just happen to be in the one that works, the one where the conditions are just right for life to emerge and flourish. And then there's the simulation hypothesis, a mind-bending idea that challenges our fundamental assumptions about reality. Maybe our universe is a sophisticated computer program, a meticulously crafted virtual world running on some unimaginable cosmic computer, and its parameters were chosen by programmers, beings far beyond our comprehension who are experimenting with different realities. As we explore the evidence for fine-tuning, the remarkable precision of the universe's physical constants, we're not just doing physics, we're not simply conducting experiments and crunching numbers. We're questioning the very nature of reality, probing the deepest mysteries of existence, and grappling with the fundamental questions of who we are and why we're here. Let's begin our journey into the heart of this cosmic mystery, a quest to unravel the secrets of the universe and our place within it. What does it mean to say the universe is finely tuned? It's a concept that dances on the edge of possibility, a delicate balance that allows everything we know and cherish to exist. Imagine a cosmic symphony, where every note, every instrument must be perfectly in tune to create a harmonious melody. Imagine baking a cake where every ingredient, the flour, the sugar, the eggs, gravity, the very force that binds galaxies together, electromagnetism, the force behind light and chemical bonds, the mass of an electron, a fundamental particle of matter, must be measured with impossible precision. We're talking about accuracy to several decimal places, a level of exactitude that seems almost unreal. Change any one value, even by a fraction, and the cake, the universe, fails to exist. It collapses in on itself, or expands too rapidly for stars and galaxies to form. The fundamental constants are so precisely balanced, like a tightrope walker maintaining equilibrium, that they allow for complexity. The intricate dance of atoms, the formation of molecules, stars, the cosmic furnaces that forge the elements of life, planets, the cradles of potential life, orbiting their stars in the vast expanse of space and life. The delicate interplay of these constants allows for the emergence of biological systems, from the simplest bacteria to the most complex organisms. It's not just one number but a suite of them, all set just right. It's a symphony of physical laws working in perfect harmony. Think of a radio dial with billions of stations, each representing a different possible universe. Only one plays the symphony of a life-permitting universe. Only one setting allows for the existence of stars, planets, and ultimately, life as we know it. Scientists call this the fine-tuning problem, a puzzle that has captivated physicists and cosmologists for decades. Why are the dials set here and not lost in the static? Why this particular combination of constants when so many others would result in a barren, lifeless cosmos? The more we learn, the more improbable our universe appears. With each new discovery, the fine-tuning problem becomes even more acute. This isn't exaggeration, it's a direct conclusion from physics. The equations themselves point to this extraordinary level of precision. The universe doesn't just permit life, it seems to cater to it. It's as if the cosmos was designed with life in mind. Is this coincidence, a cosmic fluke, a lucky roll of the dice? Necessity, an unavoidable consequence of the laws of physics, or intention? Is there a deeper purpose behind the universe's seemingly improbable existence? The answer remains one of science's greatest mysteries. It's a question that challenges our understanding of the universe and our place within it. Let's look at some of these cosmic dials up close and explore the implications of their astonishing precision. Let's delve deeper into the fine-tuning problem and see what it reveals about the nature of reality. Let's open the Cosmic Cookbook, a compendium of the universe's most fundamental recipes. Within its pages we find the instructions for existence itself, a set of parameters so precise, so delicately balanced, that they defy simple explanation, and examine the key ingredients. These aren't your everyday baking supplies. We're talking about the very fabric of reality: gravity, electromagnetism, the strong and weak nuclear forces, and a host of fundamental constants that govern their interactions. Gravity, for instance, is incredibly weak, far weaker than the other fundamental forces. It's almost as if the universe whispered, rather than shouted, its presence into being. Make it stronger, and stars burn out too fast, consuming their fuel in a cosmic blaze, leaving no time for planets to form, let alone life to evolve. Make it weaker, and stars never form. The universe would remain a cold, diffuse soup of hydrogen and helium, devoid of the energy needed to forge heavier elements. Our existence depends on gravity being in a narrow, life-permitting range, a range so specific, it feels like hitting a bullseye on a dartboard the size of the observable universe. The strong nuclear force is another balancing act, the glue that holds atomic nuclei together, preventing them from flying apart. A bit stronger, and all hydrogen vanishes, fusing into heavier elements in the early universe, leaving nothing for stars to burn and no water for life to thrive. A bit weaker, and no elements but hydrogen exist. The periodic table would be a single entry, and the complexity required for life would be utterly unattainable. The cosmological constant which drives the universe's expansion is so small that physicists can't explain it, a puzzle that has vexed the brightest minds for decades. Make it larger, and galaxies never form. The universe would expand too rapidly, preventing matter from clumping together and leaving a desolate, empty cosmos. Each of these numbers must be just right for a universe that can host life. It's not enough for one or two parameters to be finely tuned, they all need to fall within an incredibly narrow range. These aren't arbitrary values, pulled from thin air or chosen at random, they're measured, and they're bafflingly precise. We can observe them, quantify them, and marvel at their improbable accuracy. The odds of all these dials landing on life-permitting values are staggeringly small, so small that they challenge our understanding of probability itself. Yet, here we are. Against all odds, against the crushing weight of improbability, we exist. The universe's recipe is exact, and even the tiniest tweak would erase the possibility of life. It's a testament to the delicate balance that underpins our existence. This is the essence of the fine-tuning problem, a profound question that strikes at the heart of our understanding of the cosmos. Why do the numbers line up so perfectly? Is it a cosmic coincidence, a lucky roll of the dice? Or is there a deeper, more fundamental explanation waiting to be discovered? The search for answers continues, driving scientific inquiry and pushing the boundaries of human knowledge. The universe has whispered its secrets, but we are still listening intently, hoping to decipher the full story. The list of finely tuned constants is long and astonishing. The proton-to-electron mass ratio, change it and atoms become unstable, chemistry collapses and life is impossible. The strength of electromagnetism, tweak it and atoms can't form or stars can't shine. Even the number of spatial dimensions matters. 3 is the magic number for stable orbits and complex life. In 2 dimensions biology is impossible. In 4, gravity behaves differently and planets can't orbit stars. These aren't just numbers, they're the scaffolding of reality. Each constant is a rule in the cosmic game, and together they create a universe that's not just stable, but interesting. The sheer number of these coincidences has left many scientists in awe. Is it all a cosmic accident, or is there something deeper at play? The fine-tuning of these numbers is a cosmic riddle. We are the beneficiaries of this conspiracy of constants. But what does it mean? Enter the anthropic principle. We observe a life-friendly universe because only in such a universe could observers like us exist. It's a selection effect. If the universe were different, we wouldn't be here to notice. Some see this as a logical explanation, others as a philosophical shrug. The strong anthropic principle goes further, suggesting the universe must allow for life, hinting at purpose. This idea blurs the line between science and philosophy, and even opens the door to questions of design. The fine-tuning debate has become a crossroads for physics, philosophy, and theology. The mystery deepens as we search for a satisfying answer. The odds against a life-permitting universe are mind-boggling. Roger Penrose calculated the odds of our universe's initial conditions as 1 in 10 to the power of 10 to the power of 123. Imagine hitting a target the size of an atom on a dartboard as big as the universe dozens of times in a row. This level of improbability makes pure chance seem implausible. Some, like Fred Hoyle, saw the numbers and concluded it looked like a put-up job. If not chance, then what? Necessity, design, or something else? We have no theory that demands these values. That leaves us with design, a multiverse, or perhaps something even stranger. The fine-tuning problem pushes us to the edge of science and into the unknown. What could possibly explain such impossible odds? Some propose a radical answer, the simulation hypothesis. What if our universe is a computer program, and its laws are lines of code? As our own technology advances, simulating entire worlds becomes conceivable. If it's possible to simulate universes, simulated realities could vastly outnumber real ones. In this view, fine-tuning is just programming, parameters set by the creators. Our universe isn't lucky, it was designed to work. The superintellect might be a programmer, not a deity. This idea is thrilling and unsettling, suggesting our reality isn't the ultimate one. Are we an experiment, entertainment, or a history lesson for our creators? The simulation hypothesis reframes the fine-tuning mystery in digital terms. If we're in a simulation, could we ever prove it? Some scientists look for clues. Is space-time pixelated at the smallest scales? Are there programming hacks in the laws of physics? Quantum weirdness, like reality only rendering when observed, might be a clue. But we're limited by the very rules we're trying to investigate. The programmers could hide their tracks, or maybe they left a signature in the cosmos. The simulation hypothesis sits alongside the multiverse, chance, and design as possible answers. It replaces a deity with a programmer, but the ultimate mystery remains. If we're programmed, who created the programmers? We've explored the universe's exquisite order and the staggering odds against it. Is the answer a multiverse, a simulation, or a new physics we haven't discovered? Maybe a future theory will show these constants had to be this way? Until then, we're left with a profound mystery. Science lets us ask these questions and chase the clues. The fine-tuning of the universe is a puzzle to be cherished. Whether the answer is God, the multiverse, or something unimaginable, the quest is one of humanity's greatest adventures. The final question remains, who or what set the rules?